your best, give it your best guesstimate. Okay, so this was asking you to find the relative extrema. Again, extrema is just a broad term that means maxes and mins. So relative or local min and relative or local max. Okay, did you think there was any relative mins?
Yes.
Okay, where do you think that happens at? What x value?
X equals 3.
Okay, at x equals 3. So if the derivative is negative, that means the slope is negative. If the derivative is positive, it means the slope is positive. And if it's going down and then up, I agree. That would be a relative min. And of course, you don't have to make the line chart, but if you draw little lines that are going down and up, it's a little easier to see. Okay, somebody else, was there any other relative mins? No? Okay, where's the relative max?
Negative 2.
-2, I agree. Because the graph was going up, positive slope, then it started going down, negative slope, and even if you just sketch positive slope followed by negative slope, you can visualize that relative max. It's a little easier to see. So, really, they're just trying to reinforce derivative means slope. And since I've been harping you guys about that for weeks, that should be a pretty easy one. Okay, anything y'all want to ask about question 1? Okay, just start question 2. I'm not going to give you very much time on it, but I want you to see if you start the question correctly. Question 3 is the same type, so I'll give you more time on question 3 to see if you can actually do it. But I suspect most of you will probably fall into a trap on question 2. Okay, let me stop you, because this one was saying, I just want to see if you made an assumption here that often happens. Find the relative max and mins. So here's a relative max, it's topping off, and here's 2 relative mins. What is wrong with that?
It's the derivative, so the maxes and mins are when it's at 0.
Right. If you thought that, you're thinking this graph is of f of x. But if this was a graph of f of x and you were asked to find min and max values, that's an Algebra 2 skill. That's what you guys did in Algebra 2 a lot. Your teacher either gave you a calculator to graph it, or they gave you the graph and you just had to identify them. More often than not, these question types, this is not f, this is the derivative of f. And this feels pretty uncomfortable at first, but we do a lot of working with the first derivative graph. We even do a little bit with the second derivative graph. So what is true about all of these values that I'm highlighting in red?
They're positive.
Good. How do you know all of these are positive?
Because they lie above the y-axis. X-axis.
X-axis, perfect. So anything above the x-axis is positive. All of this stuff is positive. Anything below the x-axis is negative. These are negative values, -1, -2, -3. So we really know when the first derivative is positive and when the first derivative is negative, which is what we were doing on the front page and kind of what this is doing too. So it's not that it's an extremely hard question, it's just that you kind of have to twist your thinking a little bit. In fact, it may even help to say he crosses at -2, 0, and 2. That's like the critical numbers. He was positive, then he was negative, and negative again, and then positive. And if you write it out like this, then you can visualize there's a relative max at x equals -2, and there's a relative min at x equals +2. So again, don't look at this as a function graph. It's got to be the first derivative graph. Anything above the x-axis is positive, anything below the x-axis is negative. If you know when the derivative is positive and negative, you know when the graph's going up and down. If you know when the graph's going up and down, you can find where the relative maxes and relative mins occur. So again, I mean, maybe if you thought of that right away, that was enough time, but again, I suspect more than half of the people probably fell into that trap the first time. But now you know that, and so now try question 3 with that tip and see if that works out for you. Okay, so you should have 2 answers to question 4. I'm going to kind of, I don't normally spend this much work on it, but notice I highlighted anywhere where the first derivative was 0. Those are critical numbers. I put them on my number line here. Anything above the x-axis is positive, which means it was increasing from -infinity to -2.5. He was increasing from 1 to 3, and he's increasing from 3 to infinity. And then he had a negative derivative from -2.5 to -1, so he was decreasing. And then he had a negative derivative from -1 to 1, so he was decreasing. And nobody says you have to make this. Again, this doesn't even count as justification, but it's just such a good way to organize the entire thing. It makes it almost impossible to not see there's a relative max there at x equals -2.5. And since it says justify, we need to justify. But honestly, if you understand that there is a relative max there, then you've already done the justification in your head. You just need to write it on paper. Because at that point, the derivative is going from positive to negative. Okay, going down and then going down doesn't create a relative max or min. Going down and then up creates a relative min. So there's a relative min at x equals 1. If we had to justify that like it asked, it's because the derivative is switching from negative to positive. Easy justification. And then going from increasing to increasing is not a relative max nor a relative min. So just these two. These two answers and their justifications. Okay, anything you'd like to ask about that before we keep going? Okay, then let's look at number 4 together, because it does change just a little bit, the question type, but they're still trying to make it a little bit easier for you. So, find relative max and mins, like we've been doing basically all morning. So, those are going to be found first by finding critical numbers. Critical numbers are when the first derivative is 0 or undefined. But for these next couple questions, they at least found the derivative for you. Notice this is not g of x, this is g prime of x. So I don't even have to find the derivative yet. How do I know that this is never going to be undefined?
So, denominator.
Okay, well, is this ever undefined? He has a denominator.
There's no x in it.
Right, if you have a variable in your denominator, then there's places that it could be undefined. But this is never undefined. The only other way to find critical numbers is when the first derivative equals 0. So this one is already factored as well. So I could set this factor equal to 0 and solve. There's a good chance he's changing directions at -4. And I could set this equal to 0 and solve. But that one is never true. E to the x never gets to 0. You can do that algebraically, or if you remember what the graph of an exponential growth looks like, you can see that he never reaches 0. So that gives us nothing. So there's only one critical number. X equals -4 is a critical number. I need to test something to the right of that, like 0, and something to the left of that, like -5. Make sure you plug into the derivative, though, if you have more than one thing. So this would be 0 plus 4 times e to the 0. 4 times 1 is positive, so it's increasing. -5 plus 4 is negative. E to the -5th is like 1 over e to the +5th. A negative times a positive is negative. And when the first derivative is negative, the slope is negative. And when the slope is negative, your graph is decreasing. Now I've got a visual. I have no doubt that x equals 4, -4 is a relative min. And to justify my answer, because the derivative of g was negative until then, and then it switches to positive. Once you get this number line done, it took me about an extra 10 seconds to give the answer and the justification. Okay, so number 4, we started off with the derivative. I found the critical numbers. I made the number line. I tested around the critical numbers. I can see where it's increasing and decreasing, and when I can see where it's increasing, decreasing, I can list out where there's relative maxes and mins. I want you to try the same thing on question 5. 5 is already a derivative, so you're not even really doing any calculus. I guess none of your work is calculus. Understanding how it all fits together is calculus. And like I said, I'll give you a few minutes on this one. Of course, if you get hard stuck, please do what you can and then maybe just start the next question. Okay, finished or not, you at least saw where you kind of slowed down. So your first goal was finding critical numbers, so you know the places it might be changing direction. Critical numbers occur when the first derivative is 0 or undefined. Since this had no x's in the denominator, it's never undefined, but I set it equal to 0. It's a quadratic. I factored it, set each factor equal to 0, and I got 2 critical numbers. So there's 2 places it might be changing direction. There's no guarantee. So I picked numbers around every critical number. It doesn't have to be 0, -3, and -5. Just something to the left of -4, something to the right of -4, and something to the left of -1 and to the right of -1. And then just plug them in. You plug in 0 into the first derivative, you get 0 plus 0 plus 4. That's positive. Plug in -3 into the first derivative. Also, I don't know if you guys ever think of this, but did you plug them all in up here when you were finding these? That's fine if you can do that, but sometimes it's easier to plug it into the factored form, because -3 plus 4 is positive, -3 plus 1 is negative, a positive times a negative is negative. Sometimes that's easier than plugging into that, so just a suggestion. Same with -5. If I plug -5 into the factored form, I get a negative times a negative, which is positive. And if you made it that far, I would be very surprised if you didn't get it correct. There's a relative max at x equals -4, because the derivative of g is switching from positive to negative. Easy justification. And there's a relative min at x equals -1, because g prime switched from negative to positive. Answers and justification. So there's really only 2 things that are going to make these questions harder than this one. You having to find the first derivative instead of the first derivative given to you. And sometimes solving this can be harder. I mean, for some people, solving a quadratic by factoring is super easy. Some people, it's not so much, but that's just going to vary in difficulty. Okay, the next question we need a calculator for. I don't want you to get up and get a calculator. I'll just go ahead and put this one on the board, and then I'll give you a few minutes to get up and get a calculator if you need it for 7 and 8, which are the same type. So this one says, do the same old stuff, find the relative maxes and mins, but instead of doing it by hand, use a calculator to help you. So I've got a derivative graph. I could go and hopefully it's still typed in. It is. Okay. Is that the derivative there? Okay. So type it in. There's a trig function, so you do have to be in radians. I did this yesterday and I was in degrees, and then I had to redo a bunch of my work, but you can graph it. Now, your first thought's going to be, here's your relative max, here's your relative min. But that's what you did in Algebra 2. This is not the function they're giving you. That would be an easy question. They don't hardly ever ask that on the AP exam. This is the first derivative. But it's really the same thing we did a few minutes ago on questions 2 and 3. It's just that the graph was done for you instead of you making the graph in your calculator. So all of these values above the x-axis are where the first derivative is positive. All the values below the x-axis are where the first derivative is negative. To find those values, this is what we practiced in the calculator circuit a couple classes ago. So I think this goes through 1, but I can ask my calculator to calculate the 0 to be sure. Okay, and see, it's not 1. It's 1 point, I'm going to write this on my paper, 1.018. And then it's crossing right here, which is a little bit left of -1. You should not be guesstimating it's -1.1, -1.2. You have a calculator. Ask it to calculate the 0, give it left bound point, and then a right bound point. Okay, and -1.250 is another critical number. And then the third one over here, move the cursor to the left before you hit enter on left bound, move the cursor to the right before you hit enter on right bound, and then you can hit enter to skip guess. Looks like the third one was -1.922. So I'm going to switch back here. You don't have to put this on your paper, but basically, well, it probably wouldn't be a bad idea for you to do this as a reference, but I guess I won't insist. Our graph look something like that. Something like that. Okay, and boy, actually, you know, I don't know if I even really need to dive that deep into it. I just look at the graph. Do you see any relative mins?
Relative min would be -1.922 and positive 1.082.
Okay, so what do these 2 points have in common to make that correct?
They go from negative to positive.
Right, negative slope, negative derivative, to positive slope, positive derivative. So I don't know that there's really much writing we need to do down here. I can't remember very well switching back and forth. It was -1.922 and 1.018. Those were the two that were relative maxes. Sorry, relative mins. Okay, and you said perfectly why. And there was a third x-intercept, a third time where the first derivative equals 0. That doesn't mean that it's a relative max or relative min, though. So this is the other one. Is the direction of the graph have to switch here? Yes, positive slope before, negative slope after. So if it's going from a positive slope to a negative slope, he is doing a relative max, and to 3 decimal places that was -1.250. So you need to get it within 3 decimal places accurate. Don't just do the eyeball test. But as long as you're reading those graphs correctly, positive values above the x-axis, negative values below the x-axis, you should be okay there. Okay, let me give you a minute to graph 7 and 8 and do the same thing. If you need to come borrow a calculator, please come do that quickly. And I'll give you a couple minutes to do 7 and 8. I will share the answers to those two, and I'll go over them if you need me to, but otherwise we'll just skip it. Oh, and I put down the justification for question 6, but it actually says you don't even have to justify. Just tell the x values relative mins and the x values relative maxes with 3 decimals of accuracy. Like I said, I'll give you a couple more minutes to make sure you're getting those answers, but I'll put my answers on the board. Okay, if that wasn't enough time, that's fine. You can come back and do that when you catch up on something else. Is there either of these two you want me to show you my work? Any of these two that you didn't get or feel like could be wrong? You remembered how to do the calculator stuff to get it to 3 decimals? Because that's important too. Okay, I have to take that as a yes. Okay, so even if you're not finished, go ahead and jump to question 9 with me. Again, you can finish that up later or when you're ahead of the rest of us. Okay, so the only difference with question 9 now is that it is not the derivative. So they have finally moved us to where we need to be for the test for this question type. So if you want to use the first derivative test and you want to find the extrema, you should do what we've been doing on this entire worksheet. You should find the critical numbers, which is where the first derivative is 0 or undefined. So take the first derivative. If it has a denominator with x's in it, you need to set the denominator equal to 0 to figure out where it's undefined. Or where it's 0. This one's not undefined, but it looks like it is 0 at -2 and +2. Now, as we've seen from our examples today, these two are both likely to be extrema, but they're not guaranteed to be extrema. The only way to know if they're extrema and what type of extrema they are, and to know what the justification should be, that's where the number line thing comes in, the sign chart. That's a critical number. This is a critical number. Those are important because they tell us where it might be changing direction. So let's figure out what's happening between -2 and 2 by plugging in a number between those into the derivative. That's something negative. So what does that tell me about the function? The derivative is negative. It's going up or down? Down. Okay, until it gets to a critical number where it might be changing directions. So I need to see what's happening to the right of this. So maybe I'll throw 3 into the derivative. That would be positive times positive times positive, which is positive. Positive derivative means positive slope. Positive slope means it's increasing. The only other place it might be changing directions is -2. So let me see what was going on to the left of -2. Plug in something like -3 into the derivative. Positive times a negative would be positive. When the first derivative is positive, the slope is positive. When the slope is positive, your graph is increasing. Now we've got our visual. Looks like a relative max here. Just write it out. Say y. And it looks like we have a relative min here. And state y. Okay, so I did all that one for you. Number 10 is going to be the same thing, except when you do the derivative for question 10, you're going to need to make sure you use what rule? Right, make sure you use product rule. So finish copying down 9, speak up if you have a question you want clarified on 9. Otherwise, start question 10, and I will share my derivative to question 10 in a second to make sure that part's not wrong. Because if you mess up the derivative, all of your work after that's going to be for nothing. So you want to be extra careful with that piece. Make sure you use the product rule on question 10 before you spend too much time on it. I put up the correct derivative for you to check. There's product rule, and there was one step of chain rule also. And if you're having trouble solving this, you need to consider taking out a GCF. The only way you're going to solve that is by factoring like I did. I did share the final answer to 10 on the board, so those of you that are finished, if you got that right, you could go back and do those, finish up those 2 calculator questions if I didn't give you enough time, or you can move on to question 11. But I'm going to give everybody else a couple more minutes to try to get there, and I'll go over it, so if you got stuck, you can see why. Okay, if you are not able to finish that question 10 and get that same answer, then follow along with me, please. Otherwise, tune me out and work on the next question. Okay, so the derivative was certainly a little harder. It's product rule. Had to be a little more careful. And there was a chain rule step in there. Took the derivative of 5x, so we had to multiply by a 5. Solving this is not as intuitive as some of them, but factor out a GCF. And since it's this times this equals 0, you should have set this equal to 0, which never happens, and this equal to 0, which happens when x is -1/5, which is where this is coming from. But of course, just because you know at this point, it doesn't guarantee it's a relative max or min, and you don't know if it's a max or a min, even if I told you it was one, and you don't know what the justification should be. So simply getting the critical numbers is just kind of the first little hurdle. Okay, but since there's only one critical number, that makes this part a little bit quicker. Try something to the right that's easy, like maybe 0. Try something to the left that's easy, like maybe -1. Make your life as easy as possible. This is the only place it could change direction. So whatever it's doing over here is what it's doing over here. Whatever it's doing over there is what it's doing over there. It doesn't matter the number that you pick. If I plug in 0 into the derivative, again, this is a little harder for me to see, but the factored form works out better. E to the 0 would be 1. Anything to the 0 power is 1. So positive times a positive means this is positive and it's increasing. That's still not enough to know this is a relative min. It's only a relative min if this decreases. There's a chance it might increase. So we actually have to test this too. Can't take any shortcuts, unfortunately. Plug in a -1, but e to the -5 is like 1 over e to the +5. That's positive. Plug in a -1 here. This becomes negative. Positive times a negative is negative. Again, it's nice that you don't have to find the exact value. You just need to be careful enough to know if it's positive or negative. Now you can see it was decreasing to increasing, relative min. Here's where it was happening at. And our justification is the same thing as how I know. The derivative was negative, then the derivative was positive. So you got to be careful with the solving. You've got to be careful with the derivative, but the rest is pretty predictable just based on how the other questions go. Very formulaic, so it does get easier with practice. Okay, for anybody that got stuck on 10, do you still have something about 10 you need to ask? Okay, just glancing at 11, what type of derivative rule is that going to be? Very good, the quotient rule. So make sure you do quotient rule there. Don't take any unfair shortcuts that don't actually work. And what I'm going to start to do here is I'm going to start to share more of my answers here. So those of you that it's clicking with and you're doing well, you can keep on going at your pace. Okay, so there's my answer to 11 at the very bottom. So I guess I can zoom in a little bit. So work 11, make sure that you get that. If you got that, keep going. If you get stuck and need help, I will go over it once everyone has time to do so. I am going to look at question 11 now. So if you got stuck or need some help, go ahead and follow along with us here. So one way to find, we actually look at a second way in a couple classes, but one way to find relative maxes and relative mins is with the first derivative test, which implies you need the first derivative. Just based on this function, the only way to take its derivative was the quotient rule. So derivative of the numerator times the denominator left alone minus the derivative of the denominator times the numerator left alone, all over the denominator squared. And the reason I need the first derivative is because where he equals 0 and where he is undefined is what we call critical numbers, the places it might be changing direction. Now, as it stands, I don't really feel like solving this for where it equals 0 or where it's undefined because it's unsimplified. So I would probably suggest for you to at least clean up the numerator a little bit. If you distribute this, you've got 3x squareds minus 1x squared, which is 2x squareds. I'm sorry, that is way off. This is cube. This is 3x cubes minus 1x cubed, which is 2x cubed. And then when you distribute this to this, you get 3x squareds. Nothing you can do with the denominator. Now, even those of you that got this question right, you could have gotten a little bit lucky here, so you do need to make sure that you did this as well. Critical numbers come when the first derivative is 0 or undefined. So a fraction equals 0 when the numerator equals 0. So you should have set the numerator equal to 0 and solved. 0 and -3/2. But also, and I say this every single time to hope that it sinks in, it doesn't happen as often, but it's just as important. Also, where the first derivative is undefined, which is any value of x that makes you get division by 0. So also where the denominator equals 0, which is -1. There's not 2 critical numbers to this, there is 3 critical numbers. Numbers that make the first derivative 0 and numbers that make the first derivative undefined. So we really need to test around 0, around -1, and around -3/2. So we got to test around those 3 places so that we can see where it's going up and down. But of course, this is where it should be quite a bit easier. The hardest part of this question is the quotient rule, which you've been practicing for weeks, if not a month at this point. Solving the numerator for 0 and the denominator for 0. Again, it's not always easy, but at least it's not calculus. Okay, so I could test something over here, like plugging in 1 into the derivative. And personally, I'd probably work with this. This looks the nicest. So if I plug in 1 into this as positive, I plug 1 into this, well, the denominator is always positive because it's squared. Positive over a positive is positive. When the first derivative is positive, when the first derivative is positive, it's going up. It's increasing. I don't know, test something out here. Maybe -2. This would be, this one's a little bit harder, but the denominator is always positive because it's squared. 2 times -8 plus 3 times 4. That would be -16 plus 12. That's negative. Negative over a positive is negative. So have to be careful with the arithmetic, even though we don't have to get the exact value. We still got to get close. Okay, this one's going to be hard. You tried to test something between 0 and -1. So you have no option but to do a fraction. Maybe -1/2 is hopefully not too terrible. So 2 times -1/2 cubed is like 2 times -1/8, which is -1/4. Put that down. Plus 3 times x squared, which would be 3 times 1/2 squared. 1/2 times 1/2 is 1/4. -1/4 plus 3/4 would be 2/4, which, who cares? It's positive. But I did have to be extra careful about that one. That one was not easy to do without a calculator. Okay, and then finally, it could change somewhere in here between these critical numbers. So the last one I need to test is something between -1 and -1/2. Again, this one's kind of scary because obviously you don't want to be picking out things with weird fractions if you don't have to. I'm going to do -5/4 and the denominator's positive for sure. The numerator, 3 times 25/16, 125 over 64. Honestly, I think that one probably would need a calculator. I think if this was on the test, that's messy enough that it would probably be on the calculator part. So I'm going to cheat and not actually do it. I'm going to just assume that it was negative because I see the answer. But going from negative slope to negative slope does not create a relative min or max. Going from positive slope to positive slope doesn't create a relative extrema. But right here, when he goes from decreasing to increasing at sorry, I lied. I told you I was going to cheat. I was cheating by not finding this value, and you can see I still didn't even do it right. If this is a min, this one's supposed to be, sorry, this is supposed to be positive. Okay, so positive to positive to positive doesn't create any relative extrema, but right here. That's a relative min at this x value because the derivative goes from negative to positive. Correct answer, correct location, correct justification. So, anybody that did not get 11 on your own, did that clear up all the questions you had? It's your last chance. Okay. Let's try to get a couple more under our belt here with our time left. So I know a lot of you guys have already done question 12. Make sure you got, there's a relative min at x equals 5. So if you got that for question 12, you're in good shape and you can keep going. Okay, I'm going to quickly look at question 12. So if you did not get to that, or if you were getting stumped somewhere, hopefully this will help. Okay, so I know I need to find critical numbers. So derivative was just the power rule. There's no chain rule, no quotient rule, no product rule, just power rule. Need to figure out where this equals 0. So set the numerator equal to 0, but the numerator never equals 0. But also where it is undefined. So set the denominator equal to 0. That is at x equals 5. So x equals 5 is the only critical number, the only place it might change direction. Try throwing in something bigger than 5 into the derivative, and you get a positive over a positive. When it's positive, it's increasing. Throw in something less than 5 into the derivative, like 0. Just whatever's easy. You get a positive over a negative, which is negative. When the first derivative is negative, it is decreasing. Now you can see it's a relative min at x equals 5. And if it was not multiple choice and you needed to justify, it's because the derivative went from being negative to positive. That one was a little bit easier. Easier derivative, easier algebra to solve, but overall same process. Okay, everybody okay with 12? Okay, we need to make one slight adjustment, well not slight, it's a pretty big adjustment to our agenda here. So I was hoping we would catch back up and get to the book assignment. We did not, so that's okay. We'll just have to try to do just a tiny bit more next class. So you don't need to worry about doing any of the book assignment, even though it's super short, but I do want you to try to finish up this assignment 40. So if you were unable to work ahead, that's fine, but you should still only have like 5 or 6 questions total on that worksheet. So try all of those, please. Give them your best effort. The answers are on the website for you to check your work and make corrections. And we'll worry about the book assignment another day. But I do need the book assignment pages back, of course. Put those in the box, please, on your list. Okay, that's probably a good idea because then you're looking at the stuff that's relevant. Well, these are parentheses. What does that mean? For brackets, you should. But also, if you really want to calculate these two values, this is going to be a relative max or relative min. We don't care what's happening to the left or the right. It's got to change direction. So it can't go from nothing to something to be a relative. I did. Yes, yesterday I got that.
I'm going to go to
Okay. Now, of course, you guys still have about 7 minutes, so if you want to keep chipping away at that, you're always welcome to. But since there was a little bit of time, I can share with you our next puzzle. I think it was this one. Y'all have not seen this, correct? Okay. I didn't know if you knew or not.
AP officers just check over them. If somebody's dropped or is not taking the exam indicated on there, or if you're missing someone, that means they haven't gone into classroom in order to test.
Okay, I think I've checked all that, but I'll
Okay.
check it. When do you need this by?
I said next Friday, but whenever, the order really has to be done by the 15th, but if I do it this far out, it allows me to chase people down and still get them registered.
Okay, and I can turn it into.
My box, Katrina, throw it under my door or give it to me when you see me, but I can.
Okay, sounds good. Thank you.
Thank you.
Any guesses on the puzzle? I will admit I have not worked it out, but the answer is a nice whole number, so if that means anything.
What's the answer?
What do you think it is?
I don't know, the other says yes.
Huh?
The other says yes. That's what it is. I said 5.
It's not 5, but
Is it half?
huh?
Is it half a kilometer?
It's not half. I'll have to find the video, but I'll share it with you. The answer was 10. I will try to share that YouTube video with y'all in Google Classroom during advisory.
If you borrowed one of my calculators, I need it back.
Have a good day.